Good morning, students. So, in today's class, we'll be working on chapter 3.3, that is artificial sunflower. So, before we talk about artificial sunflower, you guys know what a sunflower is, right? So, sunflower is one of those flowers which actually moves with the direction of the sun. Wherever the sun is, or however the sun is moving, the flower tries to face the sun. So, that's why it's called sunflower. So, if I have to create an artificial sunflower, how would I do it? This is just a fun project where I'm going to use a DC servo motor and also a photoresistor. So you have completed photoresistor in 2.4, so you must know what a photoresistor is. A photoresistor is nothing but a resistor which is sensitive to light. So that means you can increase or decrease the amount of resistance by changing the the intensity of light. So that is called photoresistor, right? So a resistor that is dependent on the intensity of light. So we are going to use a photoresistor and we are going to use a servo motor, and then we are going to create something which is like a sunflower. Okay, so for that I want you guys to go to your Tinkercad. The circuit is super easy and also the code is very simple. Although we are going to write a text based code, it is going to be very easy. So I want you guys to write 3.3 artificial sunflower, and the first thing is definitely you would need an Arduino, you would need a breadboard. Along with Arduino and breadboard, you see this, there is something called micro servo or servo motor. It's a very small servo motor. So a servo motor, you guys know what a motor is, right? It takes the electrical signal and converts into mechanical signal. So we are going to send a signal to the servo motor from the Arduino based on the photoresistor. Search for photoresistor, you will find the photoresistor. So these are the only components that you would need. So I'm going to put this photoresistor somewhere over here, and it has terminal 1 and terminal 2. So terminal 1 will be connected to 5 volts and terminal 2 will be obviously connected to a ground. Along with that, you're going to take some signal and send it to the Arduino. Now the idea is, whenever I'm changing the value on the photoresistor, this servo motor should convert the electrical signal into mechanical signal. So for that, first I would need 5 volts, and you guys should know by now that 5 volts I always use red color. And for ground, which color do I use? I use black, then connect it over here. Now I need 5 volts to terminal 1, so I'm going to take another cable of red color and connect it from here to 5 volts. You see this? The whole vertical section over here is 5 volts. And then I need a resistor. This time I'm going to use 1 kilo ohm. Take a resistor of value 1 kilo ohm, connect it to the ground. The ground is black cable. From the terminal 2, it must be connected to the ground. Perfect. The same thing, this servo, my micro servo, also has ground and power. Power is nothing but 5 volts, so I need 5 volts. I'm going to take 5 volts from the same segment and then connect it to the, I think I connected to the ground. Power. I'm going to take a black cable and connect it from ground You just need to go to ground. Direction and how you're going to connect, it's totally up to you. I'm just trying to connect in a way that it's not going to be super cumbersome. Okay, and the third one is signal. So for the signal, I always use pink color, and I want this to be connected to signal. I want the signal to be connected to digital pin 9. So it's easy for me to write a code or right. So photoresistor is about to work, but Arduino is sending the signal to micro servo, but is the Arduino receiving any signal from photoresistor? Because it is going to read an analog signal, the amount of light, the intensity of light is going to be an analog signal. I'm going to take a green cable and connect it from terminal 2 somewhere over here to my analog signals or analog pin A0. Now I can change the intensity of light that is hitting the photoresistor. Based on the intensity of light, we are going to make a movement on this servo motor. Okay, and Arduino is going to send the signal. So with this, the circuit is done. Now it's the interesting part where you're going to write the code. I want you guys to delete the whole thing and go to text, click continue, delete everything. I'm going to try to increase the size so you should be able to see this little clearly. So first thing that I need to do is I need to include this micro servo, right? It has its own library, so I need to include that library. So I'm going to write hash include servo.h. servo. Then you're going to create a variable named my servo. See this, what I'm doing. My servo, S is a caps lock. S is a capital letter, right? So this is a variable. Whenever I'm trying to operate my servo, I'm going to use this variable my servo. Okay, whenever I'm going to operate the mini servo, I'm going to use my servo. This is a variable. Okay, now I'm going to create another one, const int sensor pin is equal to A0. Constant initialize sensor pin to be A0. So for A0, where is this connected to? It is connected to our photoresistor. So we are just initializing our sensor pin to A0. Then int sensor value is my new variable, and its value is going to be 0. Int angle. We are going to create a new variable which is angle. Okay, now void setup. Whenever you do void setup, you open parentheses, click enter. Here you are going to write, where is this my servo connected to? My servo is connected to pin number, this pink line is connected to D9, so that is digital pin 9, so I'm going to put it as 9. Okay, and then terminate the statement, and that's it. So with this, you are initializing your servo pin. Now you're just going to write the logic. The logic is void loop. You're going to create a loop because it must be continuous process, and whenever you create a void loop function, you open a parentheses, click enter, and then if sensor value see this, I need to use the exact same words or letters that I've used in line 4 as sensor value over here. Sensor value is equal to analog read. Which one are we reading? This is my pin, right? So that is a sensor pin. So sensor pin. Okay, so the next one, all you are going to do is angle is equal to, I'm going to map both of them based on the light that is received by the photoresistor. I need to change the sensor value. So I'm going to change the sensor value from map. I'm going to copy the exact same words over here, sensor value, and paste it over here. Map sensor value from 0 1023 to 0 180. You can put, I'm going to put 179. Okay, and then at the end you close the parentheses. Okay, let me do one thing. Yeah, now the next step is my servo dot right angle. So it's going to take the value of angle based on the resistors or photoresistors value, and then it's going to move your servo motors, and then finally create a delay of 15 milliseconds. Close the parentheses, close the statement and close the parentheses. With this, your code is almost done. Let us check if it is working or not. So, I'm going to start the simulation. So it looks like it's going to work. So now this is completely dark. I want you to notice this. What's happening over here is, let me hide the code. Okay, so here now there is no light hitting the photoresistor. That means it is completely dark. So the servo motor is in the rest position. But when you increase the light, it moves according to the amount of light that is hitting the photoresistor. Now, what I did was, when I was doing a physical project, not a simulation, on top of this servo motor, I connected a fake sunflower. I connected a paper made sunflower to it. So it looks like whenever you're moving the light on this photoresistor, the sunflower keeps moving. Okay, so I'm going to show that project sometime later to you guys. Maybe in next video I'll show you how the real project looks like. But in this class, I want you to, by using this video, I want you to complete the circuit and also the code. Okay, code is quite simple. All you have to do is, you need to initialize the sensor pin first and then create two variables. One is sensor value and the second one is angle, and then like whatever you did on the circuit is the exact same thing you're writing in the code, but you're going to map the values where 1023 is nothing but 2 power 10. 2 power 10 is 1024, right? 2 raised to the power 10 is like you're multiplying 2 10 times, so that is 1024. But because you started at 0, it's going to be one value less than that, so it's going to be 1023. And the second one is 0 degrees to 180 degrees. Like instead of keeping 180 degrees, I put 179 degrees. So those are the values that you're working with. So when you start the simulation and you change the amount of sunlight, the motor moves 180 degrees or 179 degrees. That is the basic idea of this line. Okay, and then you're connecting this angle and connecting this function to your servo motor by writing right angle, and then you're just creating a small delay and your circuit should work. If there is any mistake, please refer to the code and also your circuit. You should be able to figure it by yourself. But in case if you're not able to figure it out, take a screenshot and email it to me. I'll be more than happy to help you out in troubleshooting your work. Okay, so with this we complete 3.3, that is artificial sunflower. In the next video we are going to work with IR sensor or infrared sensors, and then ultrasonic sensor, and then motion detection. With this we complete chapter 3. But please be mindful that this Friday I'm supposed to grade, so I need you guys to complete 3.4, 5 and 6, and also start making documentation of each project that you have done. All you have to do is take the screenshots, put it in a document in an order, and you need to just turn it in. So once you turn it in, I will be able to grade it for you guys. Okay, thank you. See you in the next video.